Welcome to Tutorial 5, your first introduction to working with pointers. We're going to be concentrating on understanding some of the basic syntax and step into the visualization and a tiny bit of tracing of the code. There will be a hand-in for this tutorial for marks. So in the first question, you have to assume that you have these first four variables. I've got them here. So I've got tutorial open. This window over here I will use for showing the code, and the bottom window down here I will use for compilation and running, and I'll be using OneNote to draw out any memory visualizations we need to do. So for question 1, you're assuming you have these first four basic variables, 2 integers, a char, and then an actual double. And the thing you have to do for this question is 1, declare the required variables that you have here, that from A to D, so the new pointers you need to declare, and then draw the memory visualization to make sure you understand how is everything being referenced, because we're now working with specialty variables that keep addresses to other variables. So they hold addresses as their main goal, and we have to make sure we know where everything looks like in memory as we're working with it. So step A is make one uninitialized pointer that's to something of type int, and it has to be called iPointer1. Now the thing to remember here is when you're declaring pointers, if you're making a pointer that's going to be referencing a holding address to an integer variable, then you're always just starting with the type you're trying to reference, so being int, and then adding a star after the type and then giving the name. So you can see that over here, it is int, then star iPointer1. So this means it's going to be a pointer that's going to end up in the future at some point in time holding an address to an integer variable. The second one is make another integer pointer and initialize it to reference variable j. So we know j is up here, that is of type integer, and so once again we declare our variable. So int star space iPointer to say this is going to be a pointer to it. And then we have to give the address of variable j. We can't just go equals j. Like if we did that, we'd have a syntax error. What that is you're copying the value that's inside of j. So by putting the ampersand in front, this means give me the address of variable j. So it means the address of variable j will then be stored into the iPointer2. Step 3 is to make 3 character pointers. So now you're going to have char star and call one cp1 points to variable c, one name cp2 that's left uninitialized, and a third one cp that said pointing to what's called nothing or being null. So you can see that here. Char star right there, cp1 equals, and you're setting it to the variable c, which is a character, and we want to match that address, so then ampersand c. Next one is cp2, just created a character pointer, but it references to nothing. And then cp3 is explicitly set to null, saying that this is a pointer that will hold an address to a character in the beginning, but for right now it is null, meaning it's pointing to nothing in memory. And the very last one for D is to have a pointer called ptr that is pointing to the variable called average. So average is of type double, so we're making a pointer star, so double star, ptr equals, and then going ampersand avg to reference that it's pointing to the actual address of that variable. Now, what's important when working with pointers is to remember that you can't just look at the code that you're seeing here. You also have to keep a mental map in your mind or drawn out of the actual structure of memory. So that's what I'm going to draw out here now. So if we go with our variables we had in the beginning, so I'm going to make this first one I, and it has 10. The actual, you'll see the variable name, the box represents the memory, and then the value inside the box represents what it's set to. Next we have j, it's set to nothing. We have the character c, and then we have avg set to 10.3. First one is just making an integer pointer, and so called IPTR. This is set and initialized to nothing, so it still takes up memory, but there is no address or anything in there for right now. So I'll just put a line to mark that it's empty. Another one, integer pointer 2, that's pointing to j. And to reference that it's doing from here is that we will draw an arrow to say currently I pointer 2 is holding the address to j. Next we have those 3 pointers, so CP1 to CP3. CP1 is referencing C. CP2 is referencing nothing, and CP3 is referencing nothing, so being null. So right now we have 1, 2, 3, 4, 5 pointer variables and these 4 other variables. There is 3 of the pointer variables that are referencing nothing, and 2 of them are referencing specific variables. And this is going to be important because then when we do things like dereference I pointer 2, it means we're not working with this variable, we're going over here and making changes to the one that it currently references. And this can change over time. Okay. Now what's important here is understanding the syntax and knowing what type you're working with based upon the syntax. So if you're referencing or dereferencing any of the actual variables. So to keep things clear, I will have the code open here so we can see all of the actual variables that we are working with. And we work through the syntax. So we'll start with I. We look here is we have the variable I. It's just an integer variable, so this will be a type int. Next you have ampersand C, and now remember having the ampersand in front of a variable will give you back the address. So this will give back the address of the C variable. Now the star AVG, and just assuming this was seen somewhere, normally if you're seeing we're working with pointers and you see a star in front of a variable, it would, if a pointer variable, this means dereferencing. But here we go to AVG, AVG is type double, and so dereferencing is not allowed in this case, so this is actually an error. So you would get a compiled time error. Next is now a PTR without any star. So this means is, oh, okay, we're not doing any dereferencing. We're working directly with the address that's stored in that variable. And so we are still now a double pointer. So a pointer to a variable of type double. Now here with star CP1, we have to look again here. Okay, CP1 is a pointer, so it is legal to have the star in front of it here. And so this means now we're dereferencing. So we are not actually working with this variable. We're dereferencing and going to the one that it actually references, which we've seen we have the address star C. And from our memory diagram, we can see that CP1 is referencing C. So we are not working with CP1 once we do dereference. We are now working with this variable here, and this is of type char. Now a similar thing right here is that when we have the brackets right here and then the star, you know, you always evaluate what's in the brackets first. So we're dereferencing I pointer right now. So it means, okay, we're going to what it points to, so it's going to be going to an actual integer, and then it's going to increment what we have there. So what we have to look at is say, okay, well, we've got the integer pointer. Where is it referencing? So if we're basing this that these are just any instructions we had off of our memory address, we have the I pointer here, and this is null. This is not referencing to anything else, so this will be very important. So what will happen is this is all legal, so it will compile, but it will cause a runtime error when the program is actually executed. Because this right here will dereference the pointer and make it go to the actual integer variable it's referencing. And then this would be an increment off of this being a incrementing that actual integer variable. But in our case here, because it's not initialized, this will actually end up causing an error. If that was an actual integer variable that it was actually referencing, like iPointer2, we'd be going over to this other variable here like j and then incrementing that. So this causes an error, but otherwise it'd be legal and be an integer. This one right here is just a tricksy thing. You wouldn't normally ever code this, but this is again just saying the dereferencing. And so what it is, first off, is within the brackets you have the &j, so it means the address of that. And then it'll basically be treating this like a pointer, is that by going star, it's going to dereference it, and it'll actually be pointing to it again. So basically it leaves as an int. It's a weird way you wouldn't normally do it, but reading it from the brackets. So again, the &j, you're seeing there will give the address, and then it's in the brackets, then the star, because it knows that this is actually an address, will treat it like a pointer and dereference and go to that variable. So it just goes back to j. So all of this is equivalent to just using the variable j. So not needed, but just a way to practice with syntax. Next here, by going star cp1, again, what we're doing is dereferencing, so we're going from cp1 over to c. So at this time in the brackets, it's treating it as a character variable and where we're at, and then by going &, it's the address of c. Now we could have just gone cp1, and that would be the address in here, but this is the way that we're dereferencing moving over. Next here for star avg &, the issue with that one is that, again, avg is a double. So I'll say here. So we're working with an integer star that we're getting back here, which is an address. Now this one here is trying to dereference, once again, a variable that's a double, so this is actually an error. Okay, so a lot of this is just understanding the syntax first off of understanding what the & does, being giving the address of the variable, and then the star that you have, which is dereferencing, and making sure that that's on integer, like on pointers versus basic types. Now next from here, we are actually now going to go through and execute each one of these instructions, and we'll indicate if there's an error. So if it's an error, it's at compile time or runtime, and the source of the error. Otherwise, if it's a legal piece of code, we're going to actually be updating our original diagram that we had here. So what we had for memory. Okay, so each one of these, we have C equals A. We just always have to make sure, okay, where are we working with the actual variables? So here it says now that the variable C, which is a character, and is going to be set to A. Well, that's legal, so we're just updating that variable. And what's interesting to note is right now we have the character pointer, CP1, referencing A. So if we dereference this pointer here, it's going to give us back the variable a because that's what it's referencing right now. Next we have iPointer equals &I. So iPointer1 equals this, and so & is giving you back the actual address. So now your first iPointer1 will actually be referencing this one when it's dereferenced. So that is also still legal. Now right here we're seeing dereference, so star iPointer2 equals 42. We can go over to here and see, okay, it's not null, so we can follow that. So by doing the star, we're dereferencing, so we follow the arrow and we're going over to the variable now that we will work with, and it's saying that this now equals 42. So now we're updating this. So it's important to keep following all of those arrows. Next, we have a new variable being introduced. So character pointer called new pointer1 equals C. This will cause an actual error from right here. So it should be a compile time error because it's incompatible. So we're trying to make a pointer, but we're equals to C, so it's trying to copy the data that's inside of C, which is A, and put that into the pointer, but the pointer is expecting an actual address, so these types don't match. We would have to put an & in front of that to get that to actually work properly. Next, we have the integer star new pointer 2 equals I pointer. This is legal because these are both integer pointers. This one's being a new one created, so this one will just be set up so that it has the same address that is currently right now inside of I pointer 1. So in our diagram, we'd have to add a new variable. So I'm going to call this new pointer 2, and it's equals to what is pointer 1 is referencing, and that's up here to the variable I for right now. So again, that one's legal. This one here, we're making a double pointer, so a pointer to a double variable, and then it's equal to dereferencing I pointer 2, which is not going to be compatible because we're going I pointer 2, and that is going over to what is j, and these are all integers and not a number. It's not an address to a double variable, so this will actually be a compile time error. Okay, next we have double new pointer 4 equals pointer. Now pointer that we had before up here was equaling to actually average, so I didn't have it on my diagram there. I can add that in now. PTR was going to average, and now this one's making a new double pointer, which is valid. So this is a pointer to a double, PTR is a pointer to double, and it's copying over the address. So I will just get double pointer 2. New pointer 2 that I'm just abbreviating as new pointer 4, sorry. Let me get all of these correct. I did that last one wrong too. That's supposed to be new pointer 3, and this is new pointer 4, and this would be referencing up here to what pointer's going to. So getting a little weird right now is within the diagram, but it's the point of why drawing it out and following the arrows. Right here. Next we are doing dereferencing pointer 1 equals dereferencing pointer 2 plus 3. So we can just see first pointer 1 is this one, which is referencing something, so we can dereference it without an error. So that will run. We have pointer 2 right there, dereferencing, which is perfectly then adding actual 3. So what this is going to do, if we go from the right hand to the left hand side, we'll dereference this first. So that's pointer 2 going over here to 43. And then it's adding 3 to that, so we'd have 45. And then that's stored back into where we dereference pointer 1 up here. So where we had 10 before, now that'll be 45. So again, following pointer 2, which is 42, being added to the 3, and then being stored into what pointer 1 points to, which is over here to being 45. Now here, this one is dereferencing pointer 2 equals this pointer. Now here, this is being careful is that we are dereferencing the pointer 2, so we're going over here, now it's an integer variable, and we're trying to make an integer variable equal to the value that's inside of a integer pointer, and that will cause an actual error. The next line though, we're going on the second pointer 2 equals pointer 1, and that's just copying an address from an integer pointer to an integer pointer, so that's perfectly okay. So what this means now is we need to update our diagram. So we take away what I pointer was pointing to, and now it points to the same thing that I pointer 1 is currently pointing to. Here this is now doing dereferencing on a variable. Here should we go look at C, that's a character variable, that's not valid, so that will cause a compile error. Next here is a weird thing that'll come out of this, that you're seeing that pointer and the star and a space equals. This means there's a space in between, and the star for dereferencing has to be on the other side. So it should be here for dereferencing, but we're not, so this is after. So this should actually be like that. right there that you're doing a times equals. But right now this won't work because we're doing an integer timesing by the actual pointer address. So all of this is an actual error that comes out of it. So this multiplication can't be done. You can do addition and stuff with pointers, but you can't do multiplication. And so this is supposed to be the address of this times equaled by some value. So this will cause an actual error. Now AVG star from right here is that this is perfectly fine to do, but you just shouldn't have this space here. Is we're not dereferencing, that should be the times equals. So having that space causes an issue. So as long as that's not there, it would come out and you would be actually timesing average by 5.8. Next, we have once again of the dereferencing a pointer minus 8. So that would be just going to whatever integer pointer 1 is pointing to and minusing 8 from that value. But an issue before we go on here to even try changing our memory diagram is, hey, look at the left-hand side. That is just an integer pointer 2 not being dereferenced. So that is not actually a legal thing to do. So this makes for incompatible types trying to store a result of an integer into an integer pointer. So that is a compiler error. And so this here is now integer pointer 2, but it's in brackets being decremented first. So very, very important thing is that this is in brackets. So it'll dereference this first from right here, and then it will minus 1 from that value. So again, if we follow I pointer 2 right now, goes up to a variable I. So the variable I, the value that's in that will be decremented by 1. And so we'll have 44. Here, this is legal to do, is 0 is equivalent to null. And so it means pass nothing. It's better practice just to put this as actually null, but 0 you can put there. So that keyword null. So in our diagram, that now means then that integer pointer 1 is referencing nothing. Okay, a few more of these to go. So here, we're just seeing out. So this here is dereferencing character pointer 1. So we go to character pointer 1, referencing over here to C, so that will print out A to the screen. So that's no issue. C out here of dereferencing the actual character pointer 2. Character pointer 2 is not referencing anything, so it's basically null, and so this will crash the program. So this code is legal and will compile, but it will create a runtime error that will crash the program. This here will try to print out character 3, but the value that's in it, so here the character pointer, that's referencing null. There's no way to print null to the output screen, so this will actually cause an actual stream fail state for outputting. This next line right here, so this is more of a run, this would not cause a runtime error, it wouldn't crash the program, it's just going to screw up your output. The next one here, we try to dereference character pointer 3. Character pointer 3 is null, pointing to nothing, so this will crash the program, resulting in a runtime error. And then finally, saying average, which is just again a double variable, equals dereferencing I pointer 2. That is a valid thing to do. So you have I pointer 2 going dereferencing. It is up to a value, so it won't crash anything. It has 44. And an integer can be stored into an actual double from right here. So this is perfectly okay. And so this ends up meaning that your average will be 44. Okay, that's part 3. Now part 4 will be for hand in. Right now, so you have to hand this in for marks and send this to me, to your lab and to your tutorial instructor. And so given these first declarations where we have, make this a little bit bigger, is that you have a character C, double D, integer I, and integer J. And now here we see that we have a character pointer PC that's referenced to variable C. A double pointer called PD is referencing to D. An integer variable called pi1, and then another integer pointer variable that's referenced to variable I. So 1 on a piece of paper. So these are the two things that you need to hand in with this, is that you need to hand in 1, a drawing of a memory diagram of the variables that are showing right now. So based upon what you see here, I want to get a memory diagram. And part 2 is write a segment of C++ code that implements, let me move this over, that implements the following pseudocode plan. The catch here, though, is you may only use pointer variables except for referencing J in line 4, so down here. So you might write all this. So we have to write a chunk of code that goes, if the variable C equals X, then set D to 12.34, and then set P, the pointer integer 1 to reference to the variable J. Otherwise, your else set pi1 to the pointer to the same variable pi2, to whatever point pi2 is referencing to. And so the idea here is that on line 4, this is the one case where J right here can be want to get the address of the variable, but when we're working with C, D, and P1 and P2 and everything, we want to work with pointers properly. Okay, so you have to hand this in, but right now, if you're following along with the video, I will just go through a solution for this. Okay, so first off, step 1, you have to draw a memory diagram for everything that you're seeing in this first step. So following in the same format that we had before, I'll create the first variables. We have C set to nothing. We have the variable D, the double, the variable I for the integer, then J as another integer. Next we have a character pointer right here called PC that is referencing to C. Then we have another pointer to a double, so called PD, that's referencing to D. Next we have another pointer, PI1, that's referencing to nothing, so drawing the line through. And then next we have PI2 referencing up to I. So this is the memory diagram you should have gotten. So you should have practiced this before doing this, but this is also a solution for that first part and seeing these steps. And what you will have to hand in is including a picture of this. So redrawing it yourself. Please don't just submit, again, a screen cap of what I've drawn. Please redraw it yourself as practice so you followed through it. Next, we need to write a segment of code that accomplishes these steps. So I'm going to instead of using what I've had here for code, I'm going just to create a new program. And we will copy these over. So we have our starting variables at the very beginning. Now what we have to do now is convert this pseudocode, but only using the pointers. So it means we can only use these variables to make changes to the variables that are up here as practice of working with pointers. And the only time that we can directly reference one of the variables right here is this line right here where we have to give an address to it. So first thing we need to do is do an if. And we know with the otherwise it's going to have an else. So I'm just setting that up first now. Now we're going in to see if C equals the character X. So normally you'd be going C equals X, like that. So it's u equals sign to compare to it. But what we want to do now is not reference this variable directly. We want to go through the actual pointer. So we know that we have PC right now is set to reference that character. So I go PC, and this is not done yet, because if we leave this, it's going to try comparing the address that's in PC to the CX. We want to actually dereference that pointer. So if we go star PC, which means it's going to take the address that's in this pointer, go to that variable, and make the changes in it. So now we've compared from there. We've done it from the pointers. We want to do here is we want to set D equals 12.5. So normally, again, you'd be D equals 12.34. But again, we're not referencing D directly. We want to use the pointer that's referencing to that, so it's PD. I would not just go PD equals, because that'll try to overwrite the address in the pointer. I want to dereference the actual pointer to go to that variable D. And then finally, I want to set PI1 to point to the address array. So I go PI1. I am not dereferencing it because I'm trying to set this pointer what it's going to reference to, equals. And I can't just go J now like this, because that'll try copying the value that's inside of J. I want to make PI1, so the pointer 1, point to the J integer variable. So instead, I have to put the ampersand in front to say, oh no, store the address of the variable J into the pointer 1 so that it references to it. So it's pointing. Finally, otherwise, we have to go set point1 to point to the same variable as PI2. And so we want to PI1. We go PI1, we do not dereference it because we are actually, again, trying to set the address that's in there. We go to, and we want to reference to the same variable that PI2 is currently referencing. And so I don't want to just hard code knowing, oh, okay, go look up here and say in this line here that it's ampersand I. That's hard coding here. We want it to be the same address that PI2 is currently going to. So PI2. And so this will copy the address that's currently stored in that pointer. We're not dereferencing it, so the address, and I'll put it into PI1. And so it means both of these pointers, if you've gone to the else, will reference to the exact same variable. Okay, so that is your two parts. So part one that you have to hand in is make sure you've got the memory diagram that you had from this first chunk of code. So I've done that with you here, so make sure you go through these steps. Step 2 is to hand in the actual code that you wrote, so just that snippet that you had right here, which is we had these variables here, and this is that conversion using the pointers properly to actually do that. So I did it with you here to give you a little bit of help. Now, we're 32 minutes into this tutorial, but we're not too far from finishing. Next, we just need to do some actual tracing of code and the actual output that we would get. So we are once again back to the handy dandy OneNote and my horrible writing. Right here. And we want to trace through everything that we see. And so the idea is we need to have that memory diagram to keep track of where is everything currently referencing as we get the actual output. So I will draw the memory diagram first, starting with the variables that we have here. So we can see that we have one double variable called x. We have a double variable called y. We have a pointer called p and a pointer called q. P is referencing to nothing right now, and q is referencing to nothing right now. Okay, so I'll use that as my memory diagram, and then down here I will put the output to the actual program. So first step here, we have p equals ampersand x. So we're taking the address of x and storing that into p. So it means p will not be null anymore after that line. It'll be referencing to x. Next we have star p equals 14.5. So we're going here to where p is. We're seeing that the arrow right here is going down to x, so we're dereferencing, and then that means 14.5 will be put into this variable. Next we have q equals ampersand y, so we're setting the q pointer to reference to y. We're then outputting here first the star P. So dereference, follow from right here, and we're getting 14.5. We're then getting a comma with no space, so comma. And then we're getting the dereference of Q, so going from Q, following over here to Y, which has no value currently in it. And once again, I was going too fast, so I was doing the output, but I missed this one line right here while doing it, which is dereferencing Q and putting 23 into it. So that's before any of our output. Apologies about that. So that is 23.8. So on this output here, we would actually get 23.8. So it wasn't blank. I just missed this dereference line right here and assigning it in this output. After this, we're going Q equals P. So we're not dereferencing on either side, so it's copying the memory addresses over. So this means that Q will now reference to what P is referencing to. So we have it going up to there. We then output the exact same line that we saw before from above, but we've changed the output. So we have to follow that. It's dereferencing showing Q, so showing dereferencing P first. So it's going to be 14.5. Right here, and going too fast again. So referencing these ones, then we have the dereferencing Q equals 36.1. So we're going now from Q up to what it references to currently, which is X. And putting in 36.1 right here. Then we are outputting what P points to and what Q points to. And so P points to X, which is 36.1. Then a comma. And then it's outputting Q, which references up to here. 36.1. P is referenced to null after this. So that's the memory changing there. And then we're getting outputting X, comma, Y. And so we should get 36.1, comma, 23.8 based upon our memory diagram. Okay, so that's your output. Now before going on, let's go back and actually test that. So I have the code right here. We'll save that. And there you go. I'm matching 14.23, so everything here, 36, we matched, so we got the correct output. On to the next one, and the last one for this tutorial. So we can start our memory diagram quickly. So we have X, we have Y, once again then we have the pointer P, referencing nothing in the beginning, and the pointer Q, referencing nothing in the beginning. So if I go through this slowly, P equals ampersand X, so it's not null after that line. It references over here to X. We're then dereferencing P on the left-hand side, and then means we're putting 14.5 into what it references over here. Q equals P, so no dereferencing, so we're copying the addresses over, so it end up referencing the same thing that P is referencing from right here. This, if P equals Q, now this is important right here, is we're not dereferencing on either side, so we are comparing the memory addresses that's in the actual variables. So as long as I've gotten this right, we can see P equals X, we're dereferencing putting 14.5, and now Q equals P, So they're both referencing here. And so this right here, we're comparing, we're not dereferencing P and Q, so we're working with what they are. And we can see, oh, it'll have the same address because they're both referencing the same variable. So this will be true, and then we will put out 1.yes, so for output. Next, we're going Q equals ampersand Y. So we're setting it now to reference to Y. We're then once again doing a P equals Q, but now this will be false because again we're not dereferencing anything of these variables, so we're comparing the addresses and the pointers, and so we can see P and Q do not reference to the same variables, so it will not print out 2.yes, so skip over that. Next we dereference the Q pointer, and mean that we're putting in 14.5 into that. We're following here, and then now we're once again saying if P equals Q, do we get 3? And now remember, we're not dereferencing either of these, so we're still working with the addresses that's inside of here. So we're not comparing the data that's over here, we're comparing what's in the variable Q, P, and Q for pointers. They are pointing to two different variables, so this if statement will not actually be executed. And then finally we're doing here a comparison, but now we're doing dereferencing, so we're dereferencing P and E, comparing it to dereferencing Q, the values that are in there. So these are P or Q to two different variables, but now we're dereferencing, so going to here and comparing the values that are in both of the variables that they reference. Both are 14.5, so it will print out this last one. Okay, so that's your output trace for the last one. We'll go back to the actual code just to validate everything. So I will now comment out the first code trace and uncomment the second one. There we go. We got the correct output. Okay, so that is the end of the tutorial. Just make sure you follow the proper instructions to hand in 1, the memory diagram that you would get from here. So again, I can show that earlier. Oop. So that's the first memory diagram that you actually get. So this one right here, and then you actually have to change the code over for that, which was also covered earlier in the tutorial. So you need to hand in 2 things from this. Otherwise, I hope if you've made it this far into the tutorial, you're doing great and still doing good at this point in the semester. Contact me if you need any extra help.